Tell me what an asymptote is. Tell me what an asymptote is.
A line that a curve approaches.
Okay, so a lot of times people think of an asymptote as a line that a graph approaches that can never cross, right? Are asymptotes ever allowed to be crossed?
Yes.
It can, right? You know that now, right? Asymptotes, you can cross them. You cannot cross vertical asymptotes. Okay, vertical asymptotes will not be crossed. Sometimes we can cross the horizontal asymptote. For example, something like this, you might have a horizontal asymptote right here. The graph might initially cross it, but then approach it like a traditional asymptote would look. Okay? So let's talk specifically about finding asymptotes. If we look at a graph, we can see them usually, right? How do we know that an asymptote is there? Because the calculator draws a line for us, right?
Sounds right.
Okay, it sounds right. Well, let's look into it then. Okay, so consider the function y equals 2x over x minus 4. Complete the table and sketch the graph. So, if x is 1, what's 2 times 1? 2 divided by 1 minus 3?
Negative 2 over 3.
So negative 2 over 3. If x is 2, 2 times 2? Oh gosh, thank you. I was getting scared for a second. It is 4. Okay, and then 2 minus 4? So that gives us negative 2, right? Okay. 3, if x is 3, that gives us a 6 in the numerator and a negative 1 in the denominator. Yes? Okay, some of you guys are scaring me slightly. Just being honest. Okay, what about at 4? 2 times 4? 8. 4 minus 4? 8 over 0? Okay, who's the only person that can divide by 0? Chuck Norris, exactly. Is he in this class? No, then we're not doing it. Okay? Now, if you want to put hashtag undefined, I suppose you can. What do I not want you to do? Because we're smarter. I don't want you to write error. Okay? Yes, I know that the calculator might actually say error in the table, but we got to be smarter than the calculator. Okay? I honestly don't remember if it says error or if it says undefined. Does anybody have their calculator up right now? It does say undefined? Okay, so that means that people programming the calculators have gotten smarter as well. Okay? Because this is undefined, right? Why do I mean it's undefined?
Real number.
And why do I not want you to write error? It's not an error. We put in a 4 and we got something. What did we get? A number divided by 0. That's what makes it undefined. We don't divide by 0. There's not a definition of a number where we can define by 0. Fair enough? We're not going to just regurgitate what the calculator says. We need to understand what it's telling us. Fair enough? Okay? And the funny part is on your homework page, it actually says error. It is stupid. Okay? Well, it is a piece of paper, so naturally it is stupid. Okay? So what about 5? 10 over 1, so that would be 10. What about 6? 12 over 2, so that would be 6. What about 7? 14 over 3. Now, most of the time, you know I don't mind if you leave it 14 over 3, right? But what are we trying to do with these things? Graph them? Can I graph 14 over 3? No, what do I need it to be?
4 2/3.
4 and 2/3 would be better, right? 4.67 would be okay. Something like that that makes sense for me to graph. Okay? So let's go ahead and plot these points on this graph real quick. 2, negative 2. 3, negative 6. Knowing what you know from yesterday, I would like you to apply some previous knowledge. Are those 6 points enough for you to draw the graph? Yes? Okay. We know that it's curvish, right? It's a rational parent function. Like that, right? What's happening around 4? Somebody have their calculator out? We could do these in our head, but let's save a little bit of time. God bless you. Let's go ahead and fill this little table out real quick, and then we're going to have a talk about it. Okay? Anybody got these values for me? Read them.
Negative 14.
Okay.
Negative 38.
Negative 14, negative 38,
Negative 78.
negative 78,
82.
82. I'm glad I don't have to graph that.
42.
42,
18.
18. Just take one out. Just take one out.
Okay.
Is it plugged in?
Yeah.
Yeah, is it plugged in?
No, it's not. It's supposed to be.
Yeah.
No.
You can just put it into that thing in the wall. I know, I was trying to help out. Okay. All right, so what's happening around 4? Let's talk about what's happening around 4 from the left. Okay. Here is a calculus skill that you need. Are you listening? A calculus skill that you need. Okay. We need to talk about what's happening around 4 to the left. That means if we're going to approach 4 from the left, what's happening? As the x values are getting closer and closer to 4, the y values are
Low.
getting lower. Can we say that in a maybe slightly different way? Decreasing, getting smaller, things like something like that, right? So if we're talking about from the left, y values are, what did you say again? Getting smaller? Decreasing? I'm fine with that. So what about if we're talking about from the right? What does it mean if I'm asking you about from the right? Am I talking about starting at 4 and going to the right? No, I'm talking about approaching 4 from the right. So I'm approaching 4 from the right. So as my x values are getting closer to 4, what is happening to my y values? They're increasing, aren't they? So from the right, sorry this is so small, they didn't give me much room to write. Y values are increasing. Okay. What kind of asymptote is that for? How do you know it's vertical? Okay, maybe I don't understand then. Because I don't see anything at 4. You said you thought it would pop up, right? Some of you said that? Is there anything on my graph at 4?
No.
And in fact, that's how I know there's an asymptote at 4. Because nothing's there, right? How do I represent an asymptote on my graph? I draw something, don't I? What do I draw? A dotted line. Why do I draw it dotted? Because it's not really there, right? It's not really there. In fact, nothing is there. But I'm putting that dotted line, that asymptote there, to help me figure out the behavior of the graph. All right? You remember yesterday, anybody still have their homework? Let me see your homework out from yesterday real fast. Yep. I'm not worried about your handwriting. Look down here. They drew an asymptote for you right there, and they drew an asymptote for you right there. If I randomly say, here's an asymptote right here, and here's an asymptote right here, can you tell me where the graph is? If it's like generally parent function shape, doesn't it do that? Don't the asymptotes give you an idea of the behavior of the graph? It tells you where the graph is not. Does that make sense? Hey, can I write on your homework? Okay, thanks. All right. So let's do some exploration about these specific kinds of asymptotes real fast. Okay. There's 1 through 7. I need somebody just to fill in the tables of 1 through 7. Fill it on your paper. Say, I got 5, and read me the numbers on the table for 5. Somebody else do 3. Read me the tables, just the table. Okay, I don't want to look at VA right now. I don't want to look at that. We'll talk about that in a second. I just want the table values. So somebody do those real fast for me. Anybody got one yet?
I got 4.
You got 7? Read me 4 or 7.
Undefined, negative 0.25, undefined, 5/12.
5 twelfths? 2 and 2 fifths? 5 twelfths is not 2 and 2 fifths.
2 and 5/12.
5
I can't
twelfths?
simplify right now.
5 twelfths. I'll put 5 twelfths. How about that? Somebody said they had 4?
Negative 0.25,
4, yeah, no, you're 4.
negative 1, undefined, 2.
Okay. Monica?
Undefined, 0, 0.5 or 1/2, 2 cents.
Anybody else? I need 1, 2, 5, and 6.
I have 1,
You got 1? Read it.
2, undefined, 0, and 0.5.
People who haven't done one yet. I don't want to hear from a repeater.
I see why I couldn't simplify now.
Okay.
Can't do simplify.
5 twelfths is just 5 twelfths. Yeah. Okay.
I have 6,
Read me 6.
undefined, negative 1, 0.5, and 1.
Thank you. 2 more. 2 and 5.
I got 2.
Read me 2. Okay.
2 is negative 2.5. 4 is negative 6. 6 is undefined. And 8 is 8.
Okay. Somebody who hasn't done one yet, please, number 5.
I'll do it.
Thank you. God bless you.
Negative 2 is negative 0.5. Negative 1.5 is negative 2/3. Negative 1 is...
Hold on.
negative 1.
Hold on. That should be undefined. There should be 6.
Is negative 2?
Yes. Oh no, it should just be negative 5.
Yeah, is that negative 1?
Negative 5. And this one is 3.25. Thank you. All right. How do we tell where a vertical asymptote is? Where there's nothing, right? Okay, so where do you think people told me the wrong place for the asymptote was on number 1? Usually they tell me 4. Why did they tell me 4? Because it's a 0, right? It's not where the y is 0, it's where y values are undefined, right? And so where's the vertical asymptote on number 1?
X equals 2.
Why did you change what you said? First you said 2, and then you said x equals 2.
Because 2 wouldn't really be a placement on the graph.
2 is, I mean, it's kind of a number on a graph, right? But what is an asymptote? It's a line. How do we name lines?
With the function.
With something, right? It's not just a number. So in this case, we have to say x equals 2. Okay, that was excellent. That was excellent. Okay. So what about number 2? Where's the vertical asymptote? X equals 6. Where's the vertical asymptote on 3? X equals negative 3. Is this really hard? Look at 7. Where's the vertical asymptote on 7? Uh-oh. Is there allowed to be 2? Dun dun dun. Yes, there is. Okay. X equals 2. X equals negative 2. Okay. Are the vertical asymptotes related in any way to the equation? It's related, first of all, to the denominator, right? If you set the denominator equal to 0 and solve, you will get the asymptotes. Okay? This one's x equals 6. This one's x equal negative 1.5. This is x equals negative 4. Okay?
Wait, did you just have a key or did you just follow that?
I mean, I have the key, but look, what you just set these equal to 0.
Oh, the bottom.
Set the denominator equal to 0. Okay? I'm going to put this up here so that it's part of the video in case you need to go and look to see how to write domain. Because on your homework, you have to be able to write the vertical asymptotes and the domain. Okay? Otherwise, have a great day. Peace.